Welcome. So what I've done is I've made just a few videos on a topic called transformations. Our first objective is to perform translations. I have to admit this is the first time I've tried to teach through video, so I hope nothing gets lost in translation. So for those of you who don't know me, my name is Mr. Dix, and now you also know that I'm hilarious. Okay. Our first type of transformations that we're going to look at are called congruence transformations. What they do is they change the position of a figure without changing its shape or size, thus creating a congruent figure. There are three types of these. There's translations, reflections, and rotations. We're going to be talking specifically about translations today, but before we do that, I just want to give you the big picture of what do these look like. And we're going to look at Geometer Sketchpad. So a translation, all that is just a fancy word for moving something. The way you do that is you can specify how far over, so the horizontal movement, we'll choose 5 units, and you also choose how far down you want it to move. I could move it down 1, I could move it down 2, I'll move it down 2. And this resulting figure is what we call the image of the original figure. You can also reflect. To reflect, you need to specify the line over which you're reflecting. So I'm going to choose the y-axis. That's a good one. So I go to Mark Mirror. And what that's going to do is it's going to now reflect over the y-axis. See? You could also equivalently just reflect over the x-axis. The way that would work is you'd choose the x-axis as your mirror, and then you go to transform, reflect. Okay, finally, I just wanted to mention rotations to you. For that, let's rotate about the origin. You can rotate about any point you'd like, but I'd say the origin is probably the most common one that people do. So the way you do that is you specify the angle of rotation. I'm going to do 90 degrees. I could do 180 degrees. I could do 270 degrees. You see how you get an image each time. If you did 360 degrees, the image would be the figure itself, which is kind of interesting. And those are the most common rotations. You don't have to rotate by a multiple of 90, but I'd say the multiples of 90 are the most common ones. But you could, if you wanted to, you could rotate by whatever you want, 57 degrees, and you'd end up here. Okay? I also want you to appreciate that whether we were translating, reflecting, or rotating, we got a congruent figure each time. Let's get back to our translations. A translation moves every point in a figure the same distance. So here's a diagram showing you just in general what happens. You take any figure, in this case a triangle, and you're going to translate it to the right and then up. So horizontally and then vertically in general. And this is the notation that we use for that. You start with an ordered pair, x comma y, and the a specifies how far horizontally you're moving, and the b specifies how far vertically you're moving. This is a function. It takes an input as an ordered pair. Your ordered pair is your input, and your output is a new ordered pair. Also, just as a convention, our pre-images are always going to be blue, and our images are going to be red for all of these transformations. Let's take a look at our first example. Read over that for a moment. So we've got a quadrilateral ABCD. We have 4 vertices. And we've also got a rule that we're going to use to translate it. Well, that rule specifies what you're going to do to each of the x's and what you're going to do to each of the y's. It also tells us to use something called prime notation. I'm just going to keep going. So the way that works is you're going to add 3. You're going to subtract 1 from each of these. So to add 3, you're going to get a new a. But we don't want to just call it a. We're going to call it a prime. This is called prime notation. So each time we're going to add 3 and subtract 1. So we're going to get 2, 1 for a prime. For b prime, again, add 3, subtract 1. You get 2, 4. C prime, add 3, subtract 1. B prime, add 3, subtract 1. And we have all the coordinates. Now we're going to actually plot these. So here's 2, 1, over 2, up 1. This is what we're going to call A prime. Here's 2, 4. 1, 2, 3, 4. Here's 7, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. That's C prime. And finally, D prime is going to be 7, 1, right here. And then we connect the vertices to make our new quadrilateral. It is congruent to the original quadrilateral. All it is just translated. Take a look. It should make sense. Each point, in this case, for example, A, is translated over 3 and down 1. And that happens each time. Okay. Lastly, I just want to look at something a little different. So instead of giving you a rule, I'm going to give you a diagram. And I want us to see if we can figure out what the rule is. So we've got our blue triangle is translated to become our red triangle. A is 4, 3. A prime is now 0, 4. B prime is, let's see, over 3 up 2, so that would be 3, 2. And C prime is 0, 2. So what we want is a rule for how to get from XY, which is our blue, representing our blue triangle, to our red triangle. So the question is, what's happening to each X and what's happening to each Y? Well, take a look at each X. From 4 to 0, from 7 to 3, from 4 to 0. Do you notice a pattern? You have to subtract 4. So X minus 4. Let's take a look at the Y's. From 3 to 4, from 1 to 2, from 1 to 2, you're adding 1. Okay. So let's summarize really quick. Today we started talking about congruence transformations, and I focused on translations. I need you to become familiar with this notation here. And I also want you to appreciate that you can translate a quadrilateral, you can translate a triangle, but whatever you do, you're going to get a congruent figure.